Question number 4, page 9. In the following, state whether A is equal to B or not. So, for first, our answers for first, A is A, B, C, D, and B is also A is here, B is here, C and D. So, both A and B are same because in roster form there is no matter elements are where, right? So no order is important, so you can write in any order these sets in roster form. So both A and B are equal. Now for second set, A is 4, 8, 12, 16. So A is equal to 4, 8, 12, 16. And B is what is given B 4. 4 is here, 8 is here, 12, no 12 is here. So that's why A and B are not equal. So A is not equal to B because 12 does not belongs to B. So therefore A and B are not equal set because this is the given reason. Right? Now third one. It is given that A is this. So A is equal to, in third one, A is equal to 2, 4, 6, 8 and 10. And B, X is a positive even integer less or equal to 10. Positive even integer, that is 2, 4, 6, 8 and 10, right? So therefore both set are equal. So A is equal to B. Now fourth one. Fourth one is given A. What is given A? A is a multiple of 10. Now multiple of 10 means 10 1 ja 10, 10 2 ja 20, 30, right? 40, dash like this. And B is given 10, 15, 20, 25, 30, dash. B is given here. So 10 is here, but no 15 belongs to A. 10 is here, 20, 20, 30, 30, 40, 40 we get. But 15 not belongs to A, means A is not equal to B. So 15 does not belongs to A. So this implies A is not equal to B. So A and B are different set. Right? Now question number 5. Now solution of this. Are the following pairs of sets are equal? Give reason. Okay. First, A. A is given 2, 3. Now B. X. X is a solution of x square plus 5x plus 6 equal to 0. So we have to solve first this. X square plus 5x plus 6 is equal to 0. Now factorize this 6. Means 6 is 3 2 ja 6 and 6 has a plus sign, so we have to give both the same sign, and middle term has plus, so we have to give both a plus sign. So factor of these are x plus 3, x plus 2 is equal to 0. So what is your x? X is equal to minus 3. X is a minus 3, or here x is a minus 2. So set B has two elements, minus 2 and minus 3. Set B has two elements, minus 2 and minus 3. So is these both are equal? No, because both has a different elements, right? Not all elements are same. This is 2, but this is minus 2, and 2 and minus 2 are not equal. So from 1 and 2, from 1 and 2, A not equal to B. A not equal to B. And then second question. A is a letter in the word for. So A is equal to F, O, L, O already there, and W. And B is equal to Y. Y is a letter in the word wolf. So W O L F. Right? So say this is the number 1, this is the number 2. Now F, right? O. So this is O, this is O, L. This is L, this is L, and W. So this is W, this is W. So both set A and B has same elements. Therefore, from 1 and 2, A and B are equal. So from 1 and 2, A is equal to B. That is, A and B are equal set. Question number 6. From the set given below, select equal set. So we have to select which are the equal sets from given these sets. Okay. So solution. Now check A and B. So 2, 2, but 1 is not here in A. So A and B are not equal set. A and C. Right? Here again 2 is not in C. So these are not equal set. A and B. Never, 3 is not here. A and E, F, G and H. Not a single set are equal. So A is not equal to B, not equal to C. But we have to find out the equal sets only. So no need to write the A not equal to B, A not equal to C, A not equal to D like that. Now B. Now B and C, no 4 here, 4 is here, but no 8 here. So not equal. B and D, 3, 3, right? 1, 1, 2, 2, 3, 3, 4, 4. So B and D are equal. So B and D are equal. B and E, no. B and F, no. B and G, no. B and H, no. Then C. Now C with this is 3 not here. Now this not never because it has 4 elements. All has 2 elements. So no one equal. Now D has 4. This all has 2 elements. So they are not equal. Now E. These 2, but this is 0 and A. So E and G, these both are equal. So E and G are equal. Then E and H, no. Then F and G, F and H, G and H, no. So only B and D and E and G are equal sets. So this is your answer, right? Now we forget this question number 1. So now I am including here question number 1 exercise, right? 1.32, right? So which of the following set are examples of the null set? Set of odd natural numbers. Odd natural numbers. Odd natural number means 1, 3, 5, which is divisible by 2. Never odd numbers. Odd numbers 1, 3, 5, 7, 9. These are never divisible by 2. They are not divisible by 2. So this is a empty set. So our solution for solution first is empty set, either null set, right? Either you can say A is equal to 5. Now second, set of all even prime numbers. Now you know even prime numbers is 2. So this is not empty set. So not null set, either empty set. So this is not a empty set or null set, right? X is a natural numbers. X less than 5 for her. See here. X is less than 5. So see here. And X is greater than 7. Suppose we are starting from -2, -1, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So what is given? X is less than 5. X is less than 5 means you have to take all natural numbers, right? So you have to take a natural numbers less than 5. That is 1, 2, 3, 4, right? And X is greater than 7. That is 8, 9, 10. So there is no common element between them. So that means this is a null set. So this is null set or empty set. And 4, 1. Y is a point common to any two parallel lines. See, this is two parallel lines. Now which point is common to both them? Never, because parallel line never intersect. right? So this is fourth one is also a null set because parallel lines never intersects to each other, right? Because parallel line never intersects, so they are a null set. Okay. Now, new definition of subsets. You learn subsets in your lower classes, right? So a set is said to be a subset of B if every element of A, this is important, every element of A is also an element of B, then we say that A is a subset of B and is denoted by A subset B. You have to read this as a subset. You know this notation, A subset B, right? So if every element, suppose we have set A is equal to 1, 2, 3 and set B is equal to 1, 2, 3, 4, 5, right? Now see here, observe, A has 1, 2, 3 and B has 1, 2, 3, 4, 5. So every element of A, 1, 2 and 3 are a member of set B. That means from this we can say that A is a subset of B. Now it may or may not be, it's every time every element of B is also in A, is never happen or maybe happen. Then what happen? Suppose we write B is equal to 2, 3, 1, right? So every element of A are in B and then B is a subset of A. So here B is a subset of A. So it indicates clearly that if A is a subset of B and B is a subset of A, then both sets are equal set. Both sets are equal, that A is equal to B, right? So in other words, if A is a subset of A, then every A belongs to capital A and A belongs to capital B. That is A subset of B if A belongs to A implies, this is the new notation for you. So you have to read this as a implies. If A belongs to A implies A belongs to B. So if A belongs to, suppose I am taking A is equal to 1, then A is a subset of B, then A belongs to A implies A belongs to B. Suppose I am taking this as a B is equal to 2. So 2 belongs to B implies 2 belongs to B also. Suppose I am taking C belongs to A implies C belongs to B. That is, every element of A belongs to A has also belongs to B, then A is a subset of B, right? So we read this above statement as A is a subset of B. A is a subset of B if A is an element of A implies A is also element of B, right? Now as we discuss here, if A is a subset of B and B is a subset of A, then A and B are equal set. So if we want to write this everything in notation, then we can write A is a subset of B and B is a subset of A. Then if and only if, this is called if and only if, and in notation we have to write it double implies, right? So this is the brief of if and only if. So it can be written as just like this also, if and only if, I double F, right? That is A is equal to B. So another way, if A is a subset of B and B is a subset of B, then double implies either if and only if. You can write same, both has the same meanings. Now every element A is a subset of itself, right? See here A is a subset of itself. Now you learn in lower standard that every set or every element is a subset of A and phi is a subset of all set. So phi is a subset of all set, and as we learn, n is a subset of Z, right? Because all elements of n are in Z, all elements of Z are in Q, all elements of Q are in R. and all elements of R are in C. So N is a subset of Z, Z is a subset of Q, Q is a subset of R, and R is a subset of C. Suppose we want to write the subsets of sets, right? Suppose I have set A. So A is equal to, suppose 1, 2. I am writing A is equal to 1, 2. Then possible subsets of A. So subsets of A are, first, set A is a subset of itself, that is A is a subset of A, that means you have to write A. Then phi is a subset of all sets, so you have to write phi. Then 1, so you have to write subsets in brackets. Then 2, right? Then we have to take a pair, but if we take pair, then it's a 1, 2, it's already there. So here number of subsets, right? I am writing here number of subsets. So number of subsets is 4, right? So here suppose I am taking A is equal to singleton set, a singleton set, a definition, a set which contains only one element is called a singleton set. For example, if we take A is equal to x, x square minus 4 equal to 0, then what happen here? X is equal to plus or minus 2, but given condition is x belongs to n, so minus 2 never belongs to x, so x is equal to 2 belongs to n, and x is equal to minus 2 does not belongs to n, so this is not acceptable. So A has only one element, that is 2, so therefore A is a singleton set, right? Therefore A is a singleton set. So if we take A is equal to 1, then subsets are set itself, that is A. Phi is a subset of all sets, so we have to write phi, and then take a single element, that is 1, is already A, so it is A. So number of subset is 2, right? Then suppose I am taking A is equal to set 1, 2, 3. Then subsets are set itself, that is A. Empty set, null set is a subset of all set. Then separate element, that is first 1, then 2, then 3. Now pair. Pair means 1 and 2. Then 1 and 3. So first I am writing 1 and 2. Then 1 and 3. Now it's turn of 2. So 2 and 3. So 2 and 3. Now all pairs are finished. Now take a triplet. 3 elements. Means 1, 2, 3. That is A. A is itself here. So now count. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 elements are here. So in general, if a set has, suppose this is a set A. A has 2 elements, subset 4. 1 element, subset 2. 3 elements, subset 8. 8 means 2 cube. This is 2 raised to 1 and this is 2 raised to 2, right? So in general, we have a one formula for subsets. So number of subsets is equal to 2 raised to n, where n is the number of elements, right? That is, this is 2 raised to n is your general formula for subsets. Remember this. See, set A has 1 element, so number of A is 1, so n is 1, so 1 is 2 raised to 1, so total number of subset is 2, right? Set A has 2 elements, then subset is 2 raised to 2, that is 4, so set A has 4 subsets. Set A has 3 elements, so n is 3, 2 raised to 3, 8, so here you can get 8 elements of 8 subsets, right? So remember one formula for subsets, that A has n elements, then number of subsets is equal to 2 raised to n. So total number of subset is 2 raised to n, right? Now if A is a subset of B, then A is said to be a proper subset of B, and B is a power set, right? Sorry, B is a superset, not power. B is a superset, right? See here, proper subset. Let A and B be two sets if A is a subset of B, right? So if A is a subset of B, and also note one thing, both A and B are different, B different, right? Not same. So A not equal to B, then A is said to be a proper subset of B. A is a proper subset of B, and B is called a superset of A. So means A is a subset of B, then A is a proper subset. A is a proper subset and B is a superset. B is a superset, right? So remember this thing, this is very important concept. If A is a subset of B, then A is a proper subset of B and B is a superset of A. So A is proper subset of B and B is a superset of A. So you have to remember this. We discussed about the singleton definition, right?